So very good morning, students. Welcome to IIT and NEET Foundation program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome KTS Jogipet branch, all the 9th class students so far for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 9th. Our ongoing last chapter is refraction of light. Today we are entering to the session number 2. So we started this chapter yesterday. We completed one session where we discussed about what is refraction, right? Why is refraction? How is refraction? And lastly, three possible cases for refraction of light. Right? So in last class, we learned about these 4 points. That is, one is, what is refraction of light? Bending of light. Bending of light when it is travel from one medium to another medium. Can you hear me? I think there is some problem with the video. Right. So bending of light when it travels from one medium to another is called refraction of light. We have seen so many examples, various examples explaining the refraction of light. Okay. The video is not. Okay, various examples we have seen where we can discuss about the refraction of light. So why refraction of light? Because when light travels from one medium to another medium, its velocity changes. Due to change in velocity, while entering from one to another medium, there is a refraction take place. That is a clarification for why. Then what is saying? Third one is how. How is refraction? What is meant by how? Refraction, while the light enters from one medium to another medium, sometimes it is bends towards the normal, sometimes it bends away from the normal, which purely depends on the speed or medium, whether the medium is rarer medium or denser medium. When light travels from rarer to denser, due to decrease in speed, light bends towards the normal. I'll show the pictures also. But when entering from denser to rarer, it moves away from the normal. In such cases, the angle of incidence and angle of refraction sometimes is more, sometimes is less. And third and interesting case we have seen. Whenever light incident along the normal 90 degrees to the surface of the second medium, there won't be any bending of light. It will go directly with the 0 degrees Celsius angle of incident and angle of refraction. Right? So these are the things what we learned in the earlier session, which you can see here. One of the beautiful example for refraction of light, which you can do at any time. Even during the lunch time also, you can take the glass of water and you can perform this. When the pencil is placed in water, you can see the upper part is okay, but the part which is inside the water appears to be bending. You may be thinking the pencil may be broken, but when you take out the pencil, it is as it is only. It appears like that. That is because of the change of speed. Light speed is more in air when compared to water. So due to decrease in speed, light up, pencil is bent towards the normal. Right. Similarly, some more pictures I'll show. Yesterday it's not clear. See here. There are 2 cases what we discussed today. Okay, the first case, it is a second case. So one side you can see bending towards the normal, other side away from the normal. There is a various cases where refraction can be seen. And third case also there. When the light passes through the normal, along the normal, what we can find? We can find that there won't be any angle of incident or angle, everything is zero. Go straight only without bending. Okay. So before going for the refractive index, next simple concept that is depends on the ratio. That I'll show you the video. Through video, you can understand much better. So the value is also given here. After seeing that video, we'll come back to the values and see about what exactly it is. Okay. So there are two videos are there. Go through them. First is about refraction. Second one is refractive index.
If you look from above at a pencil that's partially submerged in water, you see that the part that's underwater looks kind of bent or misshapen.
See how the pencil is?
Remember that you
Appears
see
bending,
any object
not
because
bending.
light waves are coming off that object and reaching your eye. But those light waves behave differently in different materials. They travel faster or slower depending on the material. Light travels faster through air than it does through water or plastic. So when light traveling through air reaches a plastic block, for example, it slows down. To understand why the pen looks weird through water, let's forget about light for a second and picture a car travelling along a road surface, then reaching a patch of sand. Just like the light wave, the car slows down as it reaches a different material. But now, imagine the car reaches the sand at an angle. As the first wheel reaches the sand, it slows down. But for a short period of time, the other wheels continue at a faster speed. Because the wheel on one side is going slower, the whole car turns slightly. Once the whole car is on the sand, it continues in a straight line, but not the same straight line that it was travelling on along the
See how
road.
it's bending, right?
Light rays work in the same way. If light rays are moving through air and reach a different material at an angle, they'll change direction slightly. This is a ray box that we often use for light experiments. And this cover lets us beam a narrow ray of light from the bulb. If I aim the beam at the plastic block at an angle and turn the other lights in the room off, you can see the light beam is bent as it enters the plastic, and again as it exits. This happens just like the car reaching the sand. The speed of the light ray decreases as it reaches the plastic block, but then speeds up again as it exits the block. This bending of light is known as refraction. We can say that the light is refracted. Let's consider some of the details of what we're observing. First, you need to understand the word normal. Normal is a word that comes from Latin meaning at a right angle. The normal is an imaginary line at a right angle to a surface. Looking at the ray box setup, here you can see the normal drawn at a right angle to the surface of the plastic block. And when we talk about angles of reflection and refraction, we describe them relative to this line. Here, the ray, known as the incident ray, reaches the plastic block at 45 degrees from the normal. This is the angle of incidence. The ray within the block, known as the refracted ray, moves through the plastic block at 30 degrees from the normal. This is called the angle of refraction.
The speed decreases.
Because the light then exits the plastic block and returns to air, it speeds up. The emergent ray exits the plastic block at the same angle as the incident ray. In a case like this, the incident ray and the emergent ray will always be parallel to each other. So how does refraction affect how we see the pencil in water? Well, light reflected off the pencil moves away from the pencil through water, and it's refracted as it travels between water and air. It speeds up when exiting the water, bending away from the normal before reaching your eyes. Your brain assumes that light travels in straight lines, so it looks like the pencil has been bent to reach the point where you think the light beam has come from. It's because of refraction that we're able to focus on things using lenses. As a light ray reaches this lens, the ray is refracted toward the normal. Then, when leaving the lens, it is refracted away from the normal. Because of the shape of the lens, all of the emergent rays are refracted towards each other, focusing at a single point called the focal point. This is called a convex lens, sometimes known as a converging lens,
So
because the
refraction
light
takes
rays
place even in the
converge as a
convex
result of going
converts
through the lens.
concave lens also.
It's this type of lens that we have in our eyes that allow us to focus light from objects onto our retina, so we can see a clear image.
Right. So we are clear about this. So one more video is there regarding refractive index. What is our next topic? Once you see this, then later I will explain.
Consider that an incident light ray is traveling in the vacuum. Let it hits the surface of a glass and enter into it. We know that
vacuum
light is
glass.
refracted towards the normal in this case. The speed of light in the vacuum is 3 into 10 to the power 8 meter per second, while the speed of light in the glass is 2 into 10 to the power 8 meter per second. So we say that the speed of light in the vacuum is high and the speed of light in the glass is slow. Now if I ask you why the speed of light is high in the vacuum and slow in the glass, then the answer is simple. It is because the vacuum is optically rarer medium. It means that vacuum shows less resistance to the speed of light, while glass is optically denser medium. It means that glass shows more resistance to the speed of light. Thus, the first fact is that if a medium is less optically denser, speed of light is high. The second fact is that if a medium is more optically denser, speed of light is slow. Now listen carefully. How we can measure optical density of a medium? Well, refractive index measures the optical density of a medium. Let me repeat it. Refractive index measures the optical density of a medium. So refractive index is nothing but the optical density of a medium. For example, I am interested to find that how much speed of light slows down in glass with respect to vacuum. So I will find the ratio of speed of light in a vacuum to the speed of light in a glass. For instance, speed of light in a vacuum upon speed of light in a glass. We know that the speed of light in a vacuum is 3 into 10 to the power 8 meter per second, and the speed of light in a glass is 2 into 10 to the power 8 meter per second. After calculation, I get 1.5. What does this 1.5 mean? Firstly, it shows the optical density of a glass relative to vacuum. Secondly, it shows that speed of light is 1.5 times slower in glass than vacuum. Let me repeat this important point. It shows that speed of light is 1.5 times slower in glass than vacuum.
Very important, you can see this point. Refractive index is nothing but ratio. Ratio of speed of light in vacuum by speed of light in a given medium. It may be glass or water, whatever it may be. You can find. By that, you can understand that 1.5. How you got 1.5? You know that there. So see here, it is when you are dividing 3 by 10 by 10 to the power of 8, it can cancel. So you get 3 by 2. 3 by 2 is nothing but 1.5. So this 1.5 times slower means the velocity of the denser medium, that is glass, given here is 1.5 times lower, and that number indicates the refractive index. By seeing that, you can understand what is the optical density or radar. Okay. Just I'm continuing.
Hence, we therefore say that optical density and refractive index are same thing, are two faces of the same coin. So this 1.5 is also called the refractive index of the glass. Therefore, we define refractive index as the ratio of the speed of light in a vacuum to the speed of light in a specific medium is called refractive index. It is denoted by N. Mathematically, we write refractive index is equal to speed of light in a vacuum upon speed of light in a specific medium, or N is equal to C upon V, where C is the speed of light in a vacuum, which is a constant value, and V is the speed of light in a specific medium like glass, water, etc. Remember that this refractive index is also called absolute refractive index. Also noted down that when refractive index N is greater, medium is more optically denser and speed of light in it will be slow. Secondly, when refractive index n is smaller, medium is less optically denser and speed of light in it will be high. Now let me teach you that how we can solve numerical problems of refractive index.
I have to
For
solve
example,
this
the speed of light in a diamond is 1.25 into 10 to the power 8 meter per second. Find its absolute refractive index. Firstly, let me draw a freehand diagram so that you could easily understand it. Let the incident light ray is traveling from the vacuum and entering into the diamond. We know that the speed of light in the vacuum is c is equal to 3 into 10 to the power 8 meter per second, and the speed of light in the diamond is given v is equal to 1.25 into 10 raised to the power 8 meter per second. As we learned in the previous slide that refractive index n is equal to c upon v, where c is the speed of light in the vacuum and v is the speed of light in the medium like diamond. I plug in all these values in this equation. After calculation, I get 2.4. So the refractive index of the diamond is 2.4. What this 2.4 refractive index of the diamond means? Well, it means that the speed of the light is 2.4 times slower in the diamond than the speed of light in the vacuum. Thus, by this way, we can easily find the absolute refractive index of any medium. Here, let me teach you two bonus MCQs. Refractive index is unitless or it has no unit. If you ask me why, then it is because refractive index is a ratio between two similar quantities. For example, the unit of speed in numerator and the unit of speed in denominator cancel out. We therefore say that refractive index is unitless or having no unit. Secondly, absolute refractive index is always greater than 1. If you ask me why, then it is because in case of absolute refractive index, light always travel from the vacuum or rarer medium into denser medium like glass. So the speed of light always slow down in the denser medium and absolute refractive index is therefore always greater than 1. Finally, let me quickly teach you the concept of relative refractive index. Let's consider a glass and water. Let an incident light ray is traveling from the glass into the water. So it is refracted away from the normal in this case. Let glass is first medium and water is second medium. The speed of light in the glass is 2 into 10 to the power 8 meter per second, while the speed of light in the water is 2.25 into 10 to the power 8 meter per second. I am interested to find the refractive index of water relative to glass, or I am interested to find the refractive index of the first medium relative to second medium. We know that absolute refractive index n is equal to c upon v, where c is the speed of light in the vacuum and v is the speed of light in a medium like glass. So we always put the relative medium like vacuum in the numerator, while we put the medium like glass in denominator in which we find refractive index. So n is equal to speed of light in first medium like glass upon speed of light in second medium like water. Plug in all these values in this equation. After calculation, I get n is equal to 0.8. So the relative refractive index of water with respect to glass is 0.8. Also remember that relative reflective index is either smaller than 1 or relative refractive index is greater than 1 depending upon the relativity of two media. But refractive index, both absolute refractive index and relative refractive index will never.
So this is complete explanation about the refractive index, which is one of the important property of the light, right? So most important property of the light, refractive index. We discussed various, different materials having the refractive index value, which is always greater than 1. Air, ice, water, kerosene, right? And we have the turpentine oil, benzene, chrome glass, Canada Hulsum, rock salt, alcohol, carbon disulfate, dense flint glass, ruby, sapphire, diamond. So these are the values of n, small n value of the materials, which are called, this is called refractive index, is the ratio of speed of light in vacuum by speed of light in the any of the medium. The medium, what medium you are given in that medium, right? So how you understand. So what we learned today. So we'll continue in the next class. So small topic I discussed today. We'll continue same in the next class with more explanation about the laws of reflection and so many things, how the reflection takes place in plain glass, glass slab, okay, and how the properties will change for. So many things we'll learn in the coming 2 to 3 classes before completing our syllabus. This is a syllabus. We are now at the synopsis 2. Now this is the synopsis 3, where we can get the real depth, apparent depth, lateral depth, so many things. So big chapter it is. We'll try to finish up. Right? So that's all for today. So thank you very much, students of Jogipet branch. Have a wonderful day. Thank you.